Okay, we're looking at rational exponents. So we want to be able to write an expression with rational exponents. That means fractional and in radical form. We want to go back and forth between those two and be able to simplify them. So here it's showing that anything to the nth root, this is the index when you have this index. This could be written, if I have a third root, it could be to the 1/3 power. If I have a 7th root, it could be to the 1/7 power, and it does the same thing. A square root has an automatic index of 2, even though it's not written on there. And then this shows us 3 little equivalent statements on here. So if I had b raised to the x over y power, that's the same thing as the y root of b to the x. Or I could do y root of b all raised to the x power. Those all mean the same thing on there. So first example says write a to the 1/7 in radical form. So if this is to the 1/7 power, that would mean that is a 7th root of a. Then if I did square root of w in exponential form, that would be the same thing as w to the 1/2 power. Whenever it's just a square root, it's implied that that's a 2 on there, even though they don't write the 2. Alright, example 2. 49 to the negative 1/2 power. So, just like we did in the last chapter, whenever you have a negative exponent, that's not considered simplified. So we're going to move this thing down to the bottom. So I'm going to have 1 over 49 to the 1/2. Okay, 49 to the 1/2 is the same thing as the square root of 49. And luckily 49 is a perfect square, so this would be the same thing as 1/7. Alright, 32 to the 2/5. So this is the same thing. I could write this a bunch of different ways. I could say it's 32 squared to the 1/5. I could write it as 32 to the 1/5 squared. I could write it as the 5th root of 32 squared. Or I could say it's the 5th root of 32 squared. Those all mean the same thing. So it's up to you of which way is the easiest to think about it. Lots of times to me, this is really the easiest way to work with this, or doing this, because if you square 32, you're going to get some giant number. Where if I do the 5th root of 32, or 32 to the 1/5 power, so on your calculator, that means what number times itself 5 times gives you 32. So if you don't know that, you can type in 32 raised to the 1/5 power. Or you can go into the math menu, and down here you can do 5th root of 32. So that's 2. So anyway, look at this. Like this right here is going to simplify to 2 squared, because the stuff in the inside became 2, and 2 squared is equal to 4. So 32 to the 2/5 power is 4. You can type that directly into the calculator. Let's see. And it gives you that answer directly. But we want to try to do some of these mentally because there is a section of the SAT, PSAT that is no calculator, so we want to work on trying to do these without just typing them into the calculator and thinking about what they really mean. Okay, so example 3, simplifying this. So I have y to the 1/7 times y to the 4/7. So when you have the same base and they're raised to different powers here, we can simplify that by adding the exponents. So this would become y to the 5/7. Or you could say that's the 7th root of y to the 5th. It didn't tell you which form it wanted it in, so either of those would be fine. Okay, here I have a 6th root of 16 and a cubed root of 2. So working with this, I am going to take this 16, and I notice that I can actually write 16 as base 2. So 16 is how many 2's multiplied together. 2 times 2 is 4, times 2 is 8, times 2 is 16. So this takes 4 2's. So I can actually rewrite this as 2 to the 4th power. And then this 6th root, I'm going to make that 1/6 on the outside. And then here I have a 2 to the 1/3 power. So now, this I could multiply to simplify this, because a power raised to a power, we multiply those. So this would become 2 to the 4/6 over 2 to the 1/3. So that's the same thing as 2 to the 2/3 divided by 2 to the 1/3. And then just like we did last chapter, when you have the same base and they're being divided, we subtract the exponents. So this would be the same thing as 2 to the 1/3 or a cubed root of 2. Okay, one more of these to look at. So we have a 6th root of 4x to the 4th. So to simplify that, I'm going to kind of separate those. Let me draw a line here. Sorry, I got ran out of room. So this is the same thing as saying 4 to the 1/6 power and an x to the 4th to the 1/6 power. Now this 4, I can do the same thing and call it a 2 squared on here so that I have the same, I can get bases that are similar. And this would be, if I multiply those, x to the 4/6. So now if I simplify those, I have 2 to the 2/6 times x to the 4/6. So now I would add those. Oh, I don't have the same base on there, sorry. So I can simplify those though. This is 2 to the 1/3, and this is x to the 2/3. So if I wanted to put this back into a root, I have the third on both of them, so that means it's a cubed root. And I have the 2, and then this has the x squared on it still. So these seem a little bit tricky, but remember, we will practice these more in class, so don't worry if it seems a little bit crazy right now. It's because it's the first time you're seeing it, and we will practice it more together. Alright, last one. We have this formula can be used to estimate the future cost of an item due to inflation if you're looking at an item that is going to be gaining value. C represents the future cost, lowercase c represents the current cost, R is the rate of inflation, and N is the number of years for the projection. So we have a video game system that costs $390 now. How much would the price increase in 6 months with an annual inflation rate of 5.3%? So lots of times a gaming system is actually going to lose its value, so this might not be the best real life example for inflation, but we can use it to see what's going to happen here. So we have our cost is what we're going to find. Little c is our initial. Now a rate, when you put a percentage in there, you always put that percentage as a decimal. So 5.3%, if I move that decimal back, is 0.053. And then the rate is in years. If we want 6 months, that is a half of a year. So we have that fractional exponent on there. And then this I can type into the calculator. So 391.053 raised to the 1/2 power. So that means that in 6 months it will be projected to have inflated up to $400.20. What it's actually asking though is how much did it increase? So that would be $10.20 increase. That's what they're actually asking for there. Okay, so you have 2 of them to try on your own here. And for your joke, what kind of a chain is edible? It's a food chain. Okay, I hope you have a wonderful rest of your day and make sure you're kind to someone today.